Introducing Be Flexible, an innovative initiative with a clear goal to increase flexibility in the energy system. The fundamental purpose behind Be Flexible is to create an ecosystem of services, platforms, and regulation that places the customer and their needs at the center of everything. Our vision is to revolutionize the energy system, enhance coordination between distribution system operators, DSOs, and transmission system operators, TSOs, and empower stakeholders in the energy sector. The project: 21 partners, 11 pilots across 4 countries, 10.5 million budget, a 4-year timeframe. Our objectives are clear and ambitious. Design innovative business models for maximizing flexibility provided to the power system. Define, assess, and understand
Welcome back, everyone. I hope you had a nice lunch. I certainly did. I think the best part of the lunch, if the food was really good, was meeting so many people who have come from all over Europe here. And great to see so many people who I don't get to see very often, but really enjoy seeing. Reuniting with old colleagues, so really great. We are going to move to our 3rd edition of our Digital Innovation Award. And in this award, we had many applicants, and we selected the top 5 from an internal committee. But for selecting the winner of the award, that will be up to you, the audience. And so you have the QR code there. The QR code will come on again after all 5 companies have had a chance to make their pitch. And so we're going to have the companies present. They each have 3 minutes for a pitch, and we will get the companies present in alphabetical order. And so we will start with Alisea, with Giacomo Colombo Serri, who is the CEO. Oh, each one come up, okay. Well, actually, all of you bring up, and then we'll start. Okay, so actually, each one of you come up, please have a seat. And then we'll have DC Bell France, Laurent Schmidt, please come up. And then Enline Joan Galamba, please come up. And then Orbic, Borja Perez, please come up. And then Repath, Joaquin Ferrer, please come up. So now that they are all on the stage, we can go to the next slide, where indeed we will present in alphabetical order. There we go. Okay. The floor is yours.
Thank you. Good afternoon, ladies and gentlemen. It's an honor to be here this afternoon. I will present you Alisea, which is an IoT company specialized in grid material management. We talked this morning about observability of the grid. There is observability made with meters. We are doing the observability on the building, construction phase of the grid, not when the grid is in operation. And our solutions ultimately help the DSO to secure timely and efficient development of the grid in the context of the energy transition. Now to start, I will show you a testimonial of a customer showing how Alisea works. the audio is... the audio is not working? Okay, we will go without audio. So this is a utility in Austria that it's using our solution. As you can see, it's a solution made of a hardware device installed on cable drums, helping the utility in managing cable drums. So the utility have multiple advantages in managing cable drums in transparency, knowing where the cable drums and other critical material to build the grid are, and to manage the collection of the empty drums at the end of the usage. And as you can see here, we have a clear testimonial of the EVN utility in Austria using the device and appreciating the benefits. So it has to do with observability, and this is crucial in a moment where DSO are facing increasing pressure in grid hardening and modernization. And observability is important because in a complex supply chain with the depots, contractors, and construction site, the material often get lost, and there are many blind spots in managing material like cable drums. Observability alone is not enough. You need to have scale to manage it in a complex ecosystem, and Alizea is a scaled solution. More than 140,000 materials worldwide are connected with Alizea, and we have more than 50% of the E.DSO members that are using actively the technology. As you can see, this is a map with the full coverage that we have in Europe with all cable drums equipped and other materials with our technology. So real-time and automatic visibility. This allows the DSO to have a full cycle overview over the materials, so they can track from the delivery to the consumption of the cable, to the storage, to the management of the leftover, the scrap, and to the reverse logistic. All this is with data transferable in their ERP. All this brings to very meaningful impact. So we observe, we can control, and finally the customers are gaining a lot of operational efficiency. And ultimately this means having security in the grid development that is so fundamental in this energy transition phase. So this is a technology that can be vital for keeping European lights on. Thank you very much.
Thank you very much, exactly 3 minutes. And next I'll call up Laurent Schmidt for Decibel France.
Yes, good afternoon, everyone. I'm going to speak about another observability, which is behind the meter observability. We are very honored to be here. Thank you to the DSO colleague. We were surprised to be appointed, I would say, among the finalists of this opportunity, because actually it's an innovation which goes more to consumers, and I'm going to explain why it has also an impact onto grid operators. The idea came 5 years ago when I left ENSOE, that these cars, which you see here, are going soon to become batteries and to turn bidirectional, and that's going to change the way we can use them into a consumer environment. So I think it comes at a rather pivotal moment for DR flexibility in Europe, because we see different reasons for changing our way to integrate DRs, going into more deeper integration, whether for optimization of voltage controls, as what we heard this morning, or because, I would say, prices are becoming dynamic, moving towards dynamic prices. We see more and more negative price events, but as well as growing permitting complexity, moving towards flexible connection agreements, and so on. So basically, we need to rethink how we permit the deployment of renewable and storage at all levels of the energy system. So our idea has been to create a device which is for consumer to be able to aggregate as many revenue from different type of flexibility and be seen as a grid-friendly device into the energy system, in the sense that it is capable of automating reaction to a dynamic price, but in the same time it can react to aggregators operating into flexibility markets, as well as interact with flexible connection agreements. So all that in a seamless way without the consumer being aware of it. So it's of course using edge optimization, edge AI, and embedded forecast. So you see the box here. Most important is that you spend a few minutes with us on the booth there, and if you like it, to vote for us as well. What we want, of course, is to enable different use cases. One is to be able to stack flexibility revenue from different aggregators, connect with flexible connection agreement, but even going as far as powering consumers in case of extreme weather events. We know that DSOs are very reliable people, but in case of extreme weather events, you may end up having few consumers being out of power during several days, and we want this device to be grid forming as well, so capable of supplying power during that time. It shows basically how this interact with the control room environment. So what it brings is really high accurate observability onto any dispatch instruction and flexibility being operated into the device. You can see on the right part how the consumer sees this type of interaction. He sees this as an app interacting with his device, exactly like what you do on your iPhone and smartphone, and he sees it as a revenue opportunities. So very, very simple. Any interaction, it turns into a revenue. It is a device which is also planned for sharing benefit with the consumer, very important. And last but not least, we are part of several data space projects, AD in CMA in particular. So we think about making this device plug and play, easy to integrate with grid using standards such as the SIM standards. Not going to spend much time, I think I'm finished. So we are part of AD and in CMA. And we think we need a more harmonized data space moving forward to facilitate deployment of our device. So if you like us, vote for us. Thank you.
Thank you very much. And next is N-Line João Galamba.
How do I work with this? Hi, good afternoon. N-Line is a Portuguese company, and we specialized in grid observability. We do digital twins. Basically, the digital twin is an enabler of other solutions. It's a multi-physical digital twin that allows full observability of a distribution grid. We can monitor parts of the grid, the entire grid, lines, or the entire grid, which is best, of course. It is a multi-physics that works as a layer that then supports and enables a set of solutions that are important for the entire life cycle of grid operations, from planning to operations to O&M. GridSight, it's the ecosystem in which we operate. So the digital twin gives us full visibility of all thermal, mechanical, electrical, climate elements that affect a grid, which is an infrastructure that exists somewhere, someplace, integrated into a region with a certain climate, with certain generation patterns, with certain consumption and load patterns, and basically we're able to model all this in an integrated whole. We can monitor network conditions with full operational visibility. We have 3D views. We can enable optimized network model management, risk management. Our solution provides alerts. For example, when vegetation, we can plan and optimize vegetation management and pruning, and we can, by crossing weather, generation, consumption, and vegetation, we can have a full visibility of the risks that a certain grid might face. This allows us also to predict in real time, and using AI also have predictive insights into the grid status. So we can assess the grid under different critical operating conditions. We just had one of the largest sequence of events of extreme weather events in Portugal that destroyed a significant part of the medium tension and medium and high voltage distribution grid. One of the things that this digital grid, digital twin allows is to stress test the existing infrastructure, not on a line by line or component by component, but has an integrated system facing multiple stresses from extreme weather events or other things like vegetation problems. But in this particular case, we can stress the Portuguese distribution grid entirely and understand what needs to be done, not only in terms of future planning, but also in terms of operations. For example, mobilizing teams to particular areas of the grid where we've identified potential problems. This is a data-driven optimization based on physics, and we are basically enablers and supporters of optimized grid operations in all its dimensions. It is future-ready operational outcomes. What services do we deliver? Future-ready grid modernization. We can accelerate the integration of renewables, storage, EVs. We can optimize CapEx and OpEx. We can ensure full regulatory compliance, and we can deliver a more optimized grid, which is a critical enabler of the energy transition. People say that there is no transition without transmission and distribution, but I would say that there will never be a transition without optimized distribution and transmission. That's the role we play. Just to finalize, we are participated by ABB. We work with ABB on network state estimation, and one of our investors is Energy. Thank you very much.
Thank you very much. And now we'll go to Orbik.
Hello. Good afternoon, everyone. Bonsoir. Let me talk a little bit about the less known product cybersecurity. CRA is coming, Cyber Resilience Act, so many people is right now nervous about it, and the compliance burden it will be for many manufacturers and also operators. Operators themselves, however, are already used to taking care of the security of the grid, since it's a key target in the cyber hybrid warfare we are now living and facing. So this is not new. The problem is how mature can they be if the supply chain is secure enough. Of course, they can rely on their vendors, but the picture is really uneasy. Some words I've heard today: vertical wall, great acceleration. That's exactly the picture we have in front of us. The number of devices is increasing. The updates, patches are coming up every day. How to put them in the field the soonest with the right security. Of course, the ultimate barrier has always been testing, and this is where we have the challenge we are solving in Orbik. Testing, when we are talking about product cybersecurity, is mostly manual activity. This is, of course, inefficient, slow, but overall, the results are extremely inconsistent. This is leading to, many times, frustrating discussions between vendors and operators, and in all, preventing innovation. And releasing new products and improved and enhanced products is really difficult and slow. That's where Orbik Cyber Warden comes in. This is a project we've done with Iberdrola, and basically it's an automated platform performing a virtual lab to verify, to check the product cyber requirements against 62443 standard. Cutting down validation times from weeks, even months, depending on the product, down to a few hours. On the other hand, we have made a lot of stress in repeatability. So we have taken this 70-25 approach, which is the standard for accredited labs. So this is not only a tool that Iberdrola is using as a qualifying tool for the vendors, but also a tool for the vendors themselves, so because it can be integrated in their product development process and change management process. This is how it looks like. The interface, it's up and running in the Iberdrola Innovation Hub. As you can see, it's a sophisticated interface with some features like deep evidence, also to provide a good starting point for debugging and so on. So in all, we are helping Iberdrola to build trust on their assets and on their vendors, and to speed up innovation and putting in place the best products possible. All of it for the sake of a more cybersecure, reliable and dependable grid for all of us. Thank you.
Thank you very much. And we'll end just with Repath.
Managing an aging grid designed for a climate that has already shifted, that is the defining challenge for grid operators as we move towards a resilient future. Between devastating floods in Valencia, intensifying heat waves across the continent, the past is not a signal for stability. We're in an era of change. The question isn't anymore, will our assets survive the last storm? It's how do we adapt for the next 30 years of extreme events that are going to intensify. 70 billion euros annually, that's how much we need to keep the lights on. This is highlighting a gap in resilience. Repath was founded to close this gap. We're a university startup based out of the University of Hamburg. We bring world-class climate science into your operational reality. CapEx, OpEx, and today what we bring with us is climate-driven SAIDI. We've stress-tested thousands of distribution stations across Europe in order to project the minutes per customer per year that you are going to be exposed to and that are at risk under extreme events that are growing and intensifying in an uncertain future. Now, what we see in Germany, wind-driven SAIDI alone could drive 7% of your SAIDI minutes. When you look at Spain, the combination of heat and flooding could bring almost double these minutes at risk. And we look at the entire Europe. These three hazards alone can bring this risk almost twofold. What Repath offers is a resilient solution that goes bottom up. We start at the asset level. We understand at your substations and transformers what fails under climate stress, how that asset is damaged, and what critical components need adaptation. We take damage modeling into restoration time and downtime into your adaptation portfolios. Now, because we have an understanding of the asset, what we do is we take this asset-level approach into modeling how physical risk puts stress on your grids today and in the future. This allows you to detect systemic vulnerabilities, critical nodes, before they materialize. Now, what do we do with these critical nodes? Well, we help you build the business case for adaptation to your stakeholders. What we see here is a portfolio that we've adapted, showing that only looking at 41 key assets and investing in these, you're able to avoid almost €500,000 of losses by 2035. We've successfully built adaptation cases for distribution operators like Enel, who've taken our adaptation business case to their regulators in Latin America. Repath is building the analytics backbone for grid resilience. We're empowering DSOs to look into the future and adapt with confidence. Because the next time disaster strikes, it's not about infrastructure going down. It's about keeping the lights on for people in their darkest hours. I'm Joaquin from Repath. You can find me at the booth. Let's look at your minutes at risk.
Thank you very much to Repath, and indeed thank you to all 5 companies. And now we're going to move to the voting, and we're going to give you a few minutes to vote, 3 minutes to be precise. And so please use the QR code to vote on Slido, and we'll just give you a few minutes now to vote. I'm going to vote myself, so I will also use the QR code, and I will vote. So just a few minutes, and then we'll have the winner. It may ask you to enter your name and email first before you can vote. But that's just to confirm with the audience, but those will be kept, those will not be distributed in any way beyond the conference. And so voting will now end. And we have a winner. Thank you for everyone for voting. And the winner is Alisea. Giacomo Colombo Serri. Congratulations. We will take some photos. In fact, and after we distribute the certificates to the others. And we'll have may you all stand up, please, so we can, and the photographer will, and holding your certificate or award, and the photographer will take a photo of all of you together. Congratulations to Alisea, and indeed congratulations to all of you as finalists. Thank you so much. And now I would like to call to the stage Robin Kolistian from LCP Delta, which is one of our sponsors, who will present on one of their projects and talk a bit about what LCP Delta does. So a warm welcome to our sponsor, LCP Delta.
Yes, it's the project with the long name, so Charles, I didn't challenge you to repeat that. Thank you, everyone. Good afternoon. Let me get my bearings. So, yes, I'm Robin Kalustian. I'm part of the Energy Networks team at LCP Delta. Some of you might not know who we are, and I'll get into that in a second. Before that, I just want to say thank you for having us today. Thank you to the organizers for such a great event. We also attended the event last year and loved it so much that we came back to sponsor it. And yeah, today is even better and bigger. So thank you all for being here. I'm here today to talk about a project I'm really excited about. It's called Project Volt. I will tell you about the project for about 18 minutes, and I will spend about 1 minute telling you about LCP Delta. So very much not a sales pitch. Before doing that, though, I want you to stay interested and engaged, and there's no better way to do that than using a TikTok strategy, and that's called foreshadowing. So in this project, I'm gonna help you understand how we can defer costly network upgrades and reinforcement work, how we can lower energy costs for commercial and industrial users, and how we can also enable decarbonization of high-demand energy users immediately. Now, you should be interested, and you should be looking forward to this presentation. So let's get into who we are and then the project. Who we are, that's my only slide. LCP Delta is a consulting and research firm. We're based in the UK, in London, but we are pan-European. So we focus on most European countries, and we cover the entire energy transition value chain. That's from generation, you can see on the left-hand side, all the way to how energy is consumed from, I guess, a domestic perspective, but also commercial and industrial perspective. And then in the middle, and this is why we're all here today, that's for network operators at the transmission and distribution level. This gives us a really great perspective of the holistic energy transition, and so we're able to advise and help our clients get ahead. There's about 150 of us spread around, across 6 offices in the UK, in Paris, and in Berlin. For energy networks specifically, you can see at the bottom of the slide in orange what we do. We help with innovation, we help with business planning, we help with investment planning. Oh, sorry, it's not there. And we help with policy and economic impact assessment. So if you have any questions or if you need anything, we'd love to help. Now let's get to Project Volt. Before I get into Project Volt, I need to acknowledge that Project Volt is publicly funded. There's a lot of innovation funding available in the UK that's made available by Ofgem, and so I thought it would be useful. So Ofgem is the regulator in the UK. I thought it would be useful to just give you a bit of context on what funding is available and how much has been made available so far. You can see on the left-hand side for the electricity, there's close to £2 billion made available between distribution and transmission. And then on the right-hand side for gas networks, close to £500 million. That's a significant amount of public money. And so we all kind of trying to make sure that it's put to good use. And this is what Project Volt is doing. Again, to set the scene, Project Volt is set in the UK. We work in an environment where there's 9 network operators at the distribution level, split in different regions. And we are working with Northern Power Grid. Northern Power Grid is in the northeast of the UK. The main city is Newcastle, for those who know UK geography. And they serve around 8 million customers. That's roughly 4 million homes and businesses, and close to about 100,000 kilometers of lines and cables. And now let's get a bit deeper into Project Volt. On the one hand, we have the Northern Power Grid network, which is heavily constrained. You can see here a map that was an update on last year on where the network is. In red, areas that are heavily constrained. In green, less constrained. You can see that some areas have some headroom. Some areas have zero headroom, both from a demand and from a generation perspective. Essentially, you can't connect anything new to this part of the network. That's an issue because it also takes time to resolve these issues. Northern Power Grid is working on it, but again, it takes time. So they're expecting that the work will be effective by around 2030. And that's now 4 years to wait to get a new connection if you need it. But also, we're dealing with issues from commercial and industrial sites that need to grow and so need more power capacity. I have 3 examples here, and these are the customers that we'll be looking at in the project. First is Newcastle Airport. You can see that they have around 5 million passengers today, but are growing to almost 9 million. That's almost doubling their capacity. You can imagine what that does to your electricity consumption. Next, we have the Port of Tyne, which will increase its the number of containers transiting through its port by about 50%. And then we have Nissan Motors. It's an assembly line in the Sunderland Valley. That's where they, among others, manufacture and assemble the Nissan Leaf, which are investing over £1 billion to build a battery gigafactory. I don't know how to make a battery, but I know that it uses a lot of energy. So again, they need to grow, which is great for UK growth, and it's great for jobs, except they can't do it because they don't have enough power, or it takes too much time to get it. So that's kind of the premise for Project Volt. And so what is Volt? Volt is trying to be pragmatic and trying to think of how do we make sure that we're using the existing infrastructure and building new one to essentially not need network reinforcement right now. So how can we get a scalable, affordable energy system that enables these sites to grow and get more energy capacity without having to reinforce the network right now? The solution is a multi-vector microgrid. A multi-vector microgrid, it's a microgrid with a hybrid system between gas and electricity. Our focus is on renewable energy only, so we're not really looking at natural gas, but we have to acknowledge that there is a gas network there that's available, and that is providing fuel to these sites. So in the longer term, we're looking at using any kind of low carbon or zero carbon gaseous fuels. This could be hydrogen, this could be biomethane, or any other type of fuels that are low carbon or zero carbon. And so some of you might tell me, a microgrid is not that innovative. Why are you talking about this? And you're right, we have microgrids all over the world. But we have found that there's a few things that the microgrids tend to focus on and other things that tend to be ignored. First is a microgrid is not always focused on resilience. It's often focused on reducing costs. Second, it's how to get flexibility from a microgrid, how to coordinate a microgrid with the rest of the grid. And then finally, it's this multi-vector perspective. How do we make the most use of all the infrastructure that we have on site? Often microgrids focus on electricity only, not on multi-vectors. And so in Project Volt, we set out to answer 3 key questions. The first question is this even a good idea? Should we spend taxpayer money on this project? The second question, is it affordable? It requires a lot of infrastructure. It requires a lot of things to build. Can these companies actually afford it? And then finally, how can it support the grid? How can these be useful to the grid and essentially defer costly and time-consuming reinforcement work? So I'm now going to try and answer these 3 questions and leave you with, hopefully, a positive answer. So, first question, is it a good idea? Yes. 3 reasons. 1, it helps the commercial and the industrial sites with resilience. So, a big issue for this type of site, let's say an airport, is resilience. How to make sure that if the grid goes down, if there is a power outage, they can take care of the safety and security of their passengers, But more importantly, they can make sure that they communicate with the aircrafts that are taking off, landing, or planning to approach the airport. We're dealing with about 1 plane every 2 minutes at Newcastle Airport. So that's a lot of planes in a day. With the microgrid, we can ensure, well, at least with the configuration that we set up, we can ensure 100% coverage of the critical loads for 6 hours. That's more than what they have today. That's more resilience for them. And more importantly, it's zero carbon resilience. Right now, they're using diesel generators for resilience. So that's a great improvement. And that leads me to the second great benefit. It's that it lowers the carbon emissions. So with the solution, we can get to close to 100% reduction in carbon emissions from energy consumption. And again, that's great for Scope 1 and Scope 2 emissions reporting, so great for these companies. And then finally, multi-vector microgrids are great for grid coordination. By adding some generation capacity on site, we get to create surplus, tradable power. And you can see in this example, we had 10 times more export capacity on a site. Now, this is all kind of vague, and I know people tend to like to see a chart or some numbers. So I put here what the microgrid configuration could look like. We're looking here again at the airport, Newcastle Airport. You can see the different setup between solar PV, between battery storage, wind generation, as well as the hydrogen infrastructure. The hydrogen infrastructure is there, once again, to use the gas network, as well as to make sure that we use any energy that would be curtailed. So any surplus electricity that's being produced is used to produce hydrogen through the electrolyzer, and then either stored through hydrogen storage, or used to heat the airport. You can see on the chart the key benefits. So first, the load served. Using the infrastructure on site, we get to serve 100% of all the loads. That means that you get to reduce your energy costs, because once you've paid off your infrastructure, you get access to free or really, really low cost energy. Second is what I talked about, the resilience. We get to about 100 hours of coverage, and that can be spread across any load that you want. Third is on the emissions. We get to reduce the carbon emissions. And then finally, but not least, we get to essentially 10 times the tradable capacity. So this is capacity that can be exported to the grid and be part of flexibility markets. So that was question one. Question two is, how do we afford all of this? Because that's a lot of new infrastructure. I should have phrased that as a yes or no question. But the answer is yes, we can do it. I'm going to show you what we modeled it, and this is what it could cost. The numbers are quite high. We're in the tens, 15, 40 million pounds across the different sites. That's a lot of money, and we're aware that not all businesses have this kind of cash laying around to put in infrastructure. So first, it's important to think about the savings. By investing in this, you get to save over £1 million a year in your energy costs. That's massive. That's huge, even for this site. That then leads us to the payback period. That's really positive. We have payback periods around 7-8 years, which is affordable. But still, that doesn't solve the fact that you need to, bleed £40 million if you're Nissan. So how do you do it? It's the microgrid as a service business model. This is a business model that's been tested, that exists, and essentially you don't need to pay for anything using your cash. You pay for the infrastructure through a third party. So every month you get to pay a fixed monthly fee that is essentially how much energy you've consumed. And this third party takes care of owning operating, installing, and maintaining the assets. To get to this, we assessed 6 different business models, and you can see this one is the one that's scored with the highest, so 28 out of 30 in our scoring. So that's really positive, and it can be made affordable. And then the last question was, what's the benefit to the grid? Can it bring more benefits to the grid? And the answer here is yes again. I hope some of you like this. I included this for geeks around us who like looking at this kind of stuff. So to do that, essentially, we modeled a network, how a network would behave with dynamic tariffs, and how a microgrid would respond to different signals, different price signals. You can see on the top right 2 charts. First, we have, it's a bit small, it's probably a bit small. I have it here. So the top chart is the daily network demand, and then the bottom one is the daily port cost. So if we look at the top one, in red, it would be a situation where there's no microgrid, and in blue, a situation where there is a microgrid. And essentially, we're managing to lower the demand on the grid. Essentially, we're freeing up capacity for other users. That's really positive. And then the bottom chart is also positive, where we get to lower the cost for the port as well. So here we're looking at the port of Tyne, not the airport. So this is positive, it's encouraging. It's maybe not enough. You can see on these curves, it's not that inspiring, the difference between the two. And that's mostly because we're only looking at one site. So the key to this is that we need more sites. We need more of these microgrids to make an actual difference on the grid. So, can we defer costly network reinforcement and upgrades? Yes. Can we lower energy costs for these high-demand energy users? Yes. And can we enable their decarbonization now instead of in 5 or 10 years? Yes. And that's great. So that was, if you want, the giggle test. There was a 3-month project where we got to look at all this. And today is really timely because on Monday, we announced that we won funding for the next phase of this project. It's going to be a 6-month project that started in the beginning of February. It's going to run until July. All the outputs will be public and will be disseminated from September. So if you are interested, do reach out. And the key new things that we'll be looking at is, first, we're incorporating 2 new types of customers. Why? Is because we want to look at different and diverse loads. So we looked at the Port of Tyne, Nissan, and an airport. We're now adding Pulsant, that's a data center operator on the edge side, so they're not very big. And Severfield, they're a steel manufacturer. So we really get now data centers, heavy industry, manufacturing, and commercial loads. Quite a good diversity. Next, we want to better model and understand the grid coordination aspect. If we have multiple of these microgrids, how do they interact together? And if we have multiple of these microgrids, how do they interact with the grid? And what are the benefits of this? So we're going to be modeling this in more detail. On this, we're really excited that EDF joined the project. They have the biggest client base of commercial and industrial customers in the UK as a retailer, and they're also the biggest flexibility trader for commercial and industrial loads in the UK. So they can bring this real-life experience. And then finally, sorry for the person who mentioned pilotitis, but we do need to look at a pilot for this, and we have a local authority involved to help us do that. So that's me. Thank you for your time today. I hope this got you excited, and we'd love to explore whether we can do this in other countries, and if it can help, manage your network. Thank you, everyone, and we have a stand outside. I'll be there to answer any questions.
Thank you, Robin. Thank you to LCP Delta. So, indeed, now we'll come to our final panel of the day, and I would like to call up José Pablo Chávez, who is Deputy Director at the Instituto de Investigación Tecnológica, Associate Professor at the Engineering School of Comillas Pontifical University. José.
So, good afternoon. Thank you for still being here with us. This is the last panel, as has been said, last but not least, and one of the most important because it's about people, no? About all of us and the ones that are to come. And for this, to discuss what are the challenges of bringing new people on the field and on this exciting area, I would like to welcome our very good panelist, Luc de Coster from Flavius. Please come to the scene. Also, Hadrian Debold from DG Ener. Leonardo Meus, from the director of the Florence School of Regulation. Una Shorthall from Acer. And finally, my colleague, Miguel Ángel Sánchez Fournier, also member of the Prime Alliance and colleague from Comillas Pontifical University. As you can see, we have a quite diverse panel. We bring in together the industry perspective on the problem, but also the policymaker, the regulators, and also academia on the challenges to bring new people and how we can make it attractive as well to new professionals to the sector. So with that, I will start. We will start with a short pitch of 3 minutes, as agreed, on the different panelists, and maybe we will start in the opposite order to me. So, Leo, what is your insights? What do you think about the human foundations for energy infrastructure? What are the challenges from the innovation and academia?
Now it works? Yes, I think it works. Yeah, okay, great. So I think you asked me to say something about complexity, right? How complexity plays a role here.
Leo, before we go to the questions, each of you have 3 minutes just to give a pitch on topic. I mean, you can take complexity, but we will go to the questions later.
Okay, so just a general pitch on the topic of skills.
Exactly.
Okay, good. Well, the general topic of skills, I think I wanted to use that opportunity to thank E.DSO, because I don't know if you know, but we are celebrating this year the 10th anniversary of a scholarship, Ana Aguado scholarship, which is a lady that we really honored already for 10 years, and I take really this opportunity to say that we appreciate that we are doing this together. And how does it connect to skills? Well, I mean, the scholarship is all about young professionals, or even people that are just graduating and giving them opportunities, right? And I think we should do more of that, because it's also to show to young people how interesting our sector is, how certain leaders in the past have already played an important role, and how they can maybe hopefully evolve in becoming some of these new leaders. The deadline is just over, but it's an annual scholarship, and if there is anyone that wants to connect with it, I'm happy to talk to you afterwards. And it's always about the summer school and also other training opportunities that we give.
Okay, thank you, Leo. It's very competitive, but indeed very to the point, and really the training that the new generation needs on the smart grids and broader, I would say, from the energy sector. So, Adrian, your pitch, what's the message you want to share?
Is it working? Yeah. Hi, everyone. So I'll take this 3 minutes for a bit of giving out the bigger picture Here at the European Commission, we like to use the Draghi report, as you might know. It's kind of our own Bible. And Draghi had, in his report, identified that the energy transition and achieving our climate goals would necessitate at least 4 million skilled workers in the next 5 years. So it's already been 1 year, so I hope we're getting in the right direction, but the energy transition and the twin transition, to be specific, is a very intensive, labor-intensive objective. And more specifically, within grids, we will need grids for electrification and to achieve our climate objectives. And there, we're missing the skilled workforce. I read somewhere a number, I think it was in a report by E.DSO entity maybe a year ago, that 70% of DSOs are actually lacking the skilled workforce and having skills shortages. So from this observation, I think what the European Commission can do is really play at their best EU legislation and EU funding to really make sure that this workforce is ready, both for the energy transition and also for incorporating the digital transition within grids. And I'll continue developing in the later panel. Thank you.
Thank you, Adrian. Good to know that the Commission is looking at this with a lot of attention. Una, from the regulation.
Thank you. Yeah, I think from my side, I'd like to focus in on a few issues, all beginning with D by chance. But let's start with a little bit of data first. I think we live in a very exciting world at the moment, and our sector is absolutely thriving. The IEA produced some reports last year which identified the world energy employment outlook, and energy jobs growth is outpacing jobs growth in the economy generally. I mean, so it's an exciting place to work at the moment. It also means there's challenges comes with that as well. Of the 600 entities that they had responded to their survey, they found that 60% are facing critical shortages, labor shortages. So, as the Commission said, there are challenges ahead of us, but I think we also have a lot to be optimistic about. I'm going to delve into maybe 4 topics, all beginning with D, as I said. One is data and the importance of having a data-driven approach to looking at our skills needs. The second is demographics. The third is to do with diversity. And the fourth has a little bit to do with having a very deliberate career development path. But I was talking to somebody at lunchtime, and something struck me, and it just brought me back to 1962 when a US president, whose name does not begin with D, and that was JF Kennedy. And when he went to the NASA space station and he met some of the staff, and he introduced himself and he asked, "What do you do?" And the gentleman said, I'm helping to put a man on the moon. And I think, we have the same mission before us now in energy. It's just as majestic as putting someone on the moon.
Yeah. Thank you, Una. I think, each of us and everyone from the sector, we are contributing to this final goal, each in our own position, and we are all needed to make this possible. AI can take some of the tasks, but not all. Still, we need the people, and for sure that story will fit every one of us to make it possible. No? So from the industry, what are your challenges and your concerns with respect to the human capital? You're still facing any issues?
Okay, thank you very much. For starters, I want to inform the public that I'm not a specialist in human resources activities. Nevertheless, I've been active for some while in the sector, so I've seen the evolution that the sector, the DSOs, the TSOs have to go through. And I've seen the evolution from a classical top-down grid based on hardware and specific skills to entertain and power that grid. That's very fine to you. But we see the evolution to a more digitalized and a more data availability in order to introduce those things in the operation of the grid. That puts us in front of some challenges. And these challenges, we have to go and meet them. And the key word, I want to say, it's not a word today, but in fact, someone much more intelligent than I ever said that it is not the strongest of species, nor the most intelligent, but the most adaptable to changing circumstances that will survive. And what we'll see is that the change in the sector is continuously and constantly there for us. We have to live it. And the DSO has to evolve with it. And if the DSO has to evolve with it, also the skills and the people, the human capital has to evolve with it. So we have to make sure that we are able to follow the transition that we are making, that we are living at the time being, by making sure that we have the right people and the right skills on board in order to do so. And that will be the main challenge for this time being.
Does that mean that we need a continuous training of professionals? It's not like in the past that you get your degree and you are done with academics, but you see that this is a continuous process?
I would say unfortunately, but luckily, yes.
Thank you. And Miguel Angel, please, from all your experience, not only now from university, but your previous experience, how do you see this challenge?
Well, thank you very much, and it's a real honor to be here with so many friends. So on October of, by the way, Jose Pablo, I am going to use my 3 minutes. They are so kind, but on October of last year, I had the honor of presenting at the IEEE Smart Grid Technologies in Malta. My speech was about upskilling and reskilling needs for Europe's energy transition. The main conclusion I made is that talent and skills are a matter of investment. We need money for that. This is a direct link to the title of this panel. You have to invest in physical infrastructure, but you have to invest also in human talent. Una has already mentioned the International Energy Agency report that has been recently issued, the 2025 edition of their employment report. Let me outline, and I will read, but it's important. I really recommend to you you want to get into some details about this situation of the employment, to read that. It's quite a very good reference. Let me outline some of key conclusions that are really affecting directly ourselves. First, the electricity sector is now the largest energy employer. Okay? Second, skilled worker shortages have emerged as a top concern for firms, particularly in applied technical roles. Third, an aging workforce is deepening labor and skill shortages. Four, traditional technical expertise remains essential. Traditional, I underline that. Therefore, balancing the retention of these core capabilities with the integration of new technologies and competencies is becoming an increasingly complex challenge for workforce recruitment and development. 5, energy companies compete directly with tech and finance firms on salary and benefits, making it more difficult to attract top digital talent. We are facing this situation. And specifically for grids, skilled labor constraints are emerging as a key barrier to delivering grid infrastructure at the speed and scale required. Finally, the high-skilled nature of grid-related work makes that roles classified as high-skilled for grids are higher than the broader energy sector and in the general economy. As an example, technicians who typically support engineering functions, including system monitoring, equipment testing, and maintaining digital control systems account 30% more than the energy sector average. Those are things that we have to get in mind. The most important target to advance in the upskilling and reskilling is to ensure that the skills needs from the industry, both operators and equipment suppliers, are well defined to be provided by the teaching entities at all levels, not only higher education as universities, at all levels. With that purpose, E.DSO has been mentioned many times today, prepared a report entitled Upskilling Needs for the Energy Transition with a focus on digital skills. Very much based on the results of the project E.DI, it's E.DI for education, not E.DI for data. We have two projects with the same name in the union. Funded by the Erasmus Plus program and addressing the digitalization of the energy system. Now, a new project within the same program has been granted by the EC, but now focused specifically in smart grids. It's the SG skill project with a view of the overall value chain, including the consumers, new roles, and of course, for all educational levels. In this project, we are going to develop full training programs and contests for smart grids with the purpose of delivering a practical catalog, but this is going to be a short future because the project has been already started. So this is my general idea that I would like really to share with all the audience.
Thank you, Miguel Angel. You use a little bit more than 3 minutes, but that's fine. We are on time. Just let's get to more details. I think it was a little bit, and thank you for this background. I think it was very complete to understand what are the challenges that we are facing, different reports, just also to give two more numbers. Apart from, according to the European Commission, there is more, in 5 years, more than 1 million of new engineers that are needed. And according also to the European Commission, 50% of the companies, electricity companies, they face in the smart grids bottlenecks in terms of hiring and finding professionals in the sector. So this is a serious bottleneck also to deploy and develop the networks and all the components and the intelligence that we need. So in this line, Yuna, what are the main challenges? You referred to the 4 ones, and can you mention some initiatives that can give some hope in this note?
Yeah.
Right.
Hello? No. You have me? Okay. Yeah, I just to pick up on something that Miguel had said there, you know, in the energy sector, where it's not just us that's facing a huge energy skill shortage. It's across all the sectors. It's the same people. You know, there's a talent war out there. And, you know, it's the same people. It's people with digital skills. It's engineers. And it's not just intersectional as well. It's also intra-sectoral competition too. And that's why I think it's really important that we look at it from a data-driven perspective. What are the skills, gaps, needs that we really, you know, we need to identify that. I'd just like to point to one exercise that was done by Wind Europe, a very thorough exercise. They've produced a report just before Christmas, and it's on the European wind employment needs. And, you know, they're saying that they need to go from 442,000 to 600,000, that's indirect and direct, by 2030. That's absolutely massive. The level of granularity of the data that they produce in the report is really, really interesting. Because, you know, when you know where we are at the moment, you can then calculate where we need to be. And with that as well, you can identify where exactly are the skills gap. And they have done it across 235 different job profiles. And maybe we don't need to do that in transmission and distribution to that level, but it's certainly, you know, a very powerful exercise then when you can go back to government, you can go back, you know, you say, you know, educational institutes, institutions or whatever, this is the level of detail that we need, and this provides a solid base, I think, going forward. The second thing I just wanted to say is that demographics. The IEA report as well identifies that we don't only have an aging population, we have an aging energy workforce, and that brings with it certain challenges as well. So, for example, you have people retiring, you have people at a different level in terms of care responsibility, sickness, everything. So you have a lot more people at that age retiring than you have people coming in. And that means, in essence, we can't just look at the current graduates coming out, we have to look beyond that. So how do we think about maybe retaining some of those people and building later life careers as well for people at later stage of their careers, constantly upskilling, reskilling, retraining those people. The next D that I had in mind is diversity. We know that the energy sector is very male-dominated. At the moment, it's about 20% representation of women in the sector. And that's quite an incredible statistic, 4 times more men than women. I mean, I think there's a real opportunity there to attract more, both boys and girls into the sector, of course. And to do that, you need to catch them early. You need to catch them really at the primary school level. I know some of our regulators, for example, the Greek regulator does great work going directly into classrooms, not just talking about, regulatory jobs, but across the whole spectrum of the energy sector, and just showcasing, the different types of jobs that are there, everything from electricians, engineers. So it's important to talk, I think, about the vocational trade jobs as well as the degree level positions too. There's a lot of initiatives to try and get more women in, like the Florence School of Regulation has a very promising, where it highlights, initiative that highlights women in energy. The European Commission has similar. They have an energy equality platform where they really encourage people to look at, to promote diversity and inclusion within the sector and encourage everyone to join that platform. The IEA has a similar equality and energy transition platform where they're looking at gender data. But there's loads of initiatives as well at the company level too. And that's as simple things like, providing placements for people to get on the job practical experience. You said earlier, do we need to do more, or is it just, is it just one job that you stay in, or is it reskilling? And I think we all agree it's about reskilling constantly and catering for later learners at all times of their career. So getting more people in and retaining the people that we have as well. And I think that's, having that sort of very deliberate career choice and career path for people is very important. So it's one thing, for example, to get women in, but if you're in and then you're not getting opportunities, or you're being, so it's really important to showcase the different career path opportunities, both in terms of courses, but also later as well.
Yeah, thank you very much. I think this is clear. You mentioned how to retain. One is on retention, and one sometimes is about social norms. The engineering has been traditionally seen as a male career, and a lot of efforts. I think the Florence School of Regulation is, as mentioned before, a good example, putting these women on energy, trying to bring more women into the sector. Half of the population that we can try to bring it with us, and still is a minority. Is really sad to see, for instance, in my university, the last graduates from PhD in engineering, all of them were male. So it's still beyond the efforts we are putting on this, is hard. It's a challenge, but we have to intensify these, I think, initiatives to make it more attractive as well for women. And also another is how to retain good talent, people that are already retired. We have an example here. I won't tell the name, but that still is working and bringing all the knowledge over the past career. Yeah, that's also much needed because we're lacking of people. No? So thank you. In that respect, maybe from the industry point of view, how can we, Fluvius, do you have from your company examples of how you are trying to attract talent? And do you think this talent needs to have the traditional engineering knowledge, but also knowing as well some new skills related to machine learning, to AI, to how to combine these two words into one person, and how to, any ideas that you want to share for others here?
Just if you allow me, yes, this functions. The question you ask is indeed the challenger, because I think for the time being, every grid operator and tech sector is facing the same challenges. Is this mic functioning like it should be? Yeah, okay, thank you, sorry. So they're all facing the same challenges. I already explained to you the modification that the grid went through, and we have to try to, instead of thinking about the grid, we have to start thinking about the system. And the system has changed very strongly. It has been digitalized and is becoming much more complex. And this needs that we need to incorporate people who also are able not only to have indeed the classical pattern of the process engineer, but also are able to think and evolve with the changing in the system for itself. So we have to make sure that we get all the capabilities we need on board. And I have to admit that it's not easy today. But what do we today? What do we have to do today? Is in fact, what we do is we're hiring in pairs. Meaning we hire engineers, we hire data scientists, because the people who have those two capabilities are very scarce on the market, and as you said, there is a hunt for talent on that matter, and so it's very hard to find them. So when you get them on board, then you have to apply them in pairs. So we apply them in pairs, so the team is at least bilingual and is able to solve solutions, to bring solutions that neither of them both individually could not bring forward to them. So it's very important to do that way. So then you have to go upskilling the people that you have on board, because also, as I thought, finding people on the market is very hard. They are not very specific trainings on board in the market at universities who will prepare people to all those skills in one time. So you have to go on in-company training to make sure that those skills are shared. And that is a very strong challenge, but you have to do it. If you don't do it, there is a problem with it. And what we also do in hiring people is we have finally started fishing out of our normal scope of where we recruit people. Because 10 years ago, you had to be a civil engineer with a PhD in energy systems, and then you were good to come and work in the company. But now this is not true anymore. We hire people from automotive sector, from electronic sector, for everyone to make sure that these people bring in the new insights, and we can occupy, use, or learn from those new insights from those people. So it's very important. But this is what we do for the time being. But we could do more, as already mentioned by my colleagues. And we think we should focus more on building partnerships with universities. And I say now universities, but that's only maybe a management level, but it's in all different levels of technical people coming into the organization that needs to be digitalized, for example. So it's in all levels that we have to do. So we have to build partnerships and make sure that the curriculums from universities, for example, that they take into account the different capabilities which are needed by each people. So, but that's something you cannot do alone. We work together with the University of Leuven. We work together with the University of Ghent. We give lectures to them. We invite them to our offices and to make sure that they can be trained on our installations, etc. We make projects with them together so they can do data analytics on real life data from our grid, so to get the interest. But you have to make a structural reform of education in order to have those people on board. So that is very sure. And next to finding those people and training those people, you have to rethink the way you are recruiting. Today we are recruiting the classical pattern, meaning we hire and we put an ad in the newspaper and say, we need a process engineer. Well, if you're looking for a process engineer, you will get a process engineer. And that's not what we need anymore. So you also have to think the part of creating and developing people. You have to make sure that you have also a career path into your company for those bilingual experts. And so you can you can get them into your house, and you can train them and further development into the energy sector. And that's what we were thinking about. Now, just maybe if I talk too much, you have to tell me, but I just wanted to point out the role of what we do in E.DSO. Because E.DSO is mainly an organization which is, in fact, the interface between the DSOs and the European institutions. And so that's clear for everybody. And we are very strictly organized, meaning we have innovation and research committees, policy and regulation committees, technology and knowledge committees, and there's all platforms where we use to interchange information on specific topics. Not only, luckily, not only technical topics, but also digitalization, etc., cybersecurity. So we take all those things with us also, and the E.DSO is forming a very important platform to interchange this information. And hidden in all those organizations, we also have something like the Task Force Skills. The Task Force Skills is there to make sure that the goal from E.DSO is also to close the gap towards the specific skills that we need in the energy sector. So they have a very, I would say, challenging scope of things they have to do. And two things I want to point out that they are active a bit is the first is really sharing information, sharing best practices, and doing that. They have designed, especially within the platform of E.DSO, a platform to share best practices and to make sure that those cases are visible to everyone, so every partner can learn from the practice that we have. It's very important that we can do so. And the second thing that we are aiming for is looking on how to develop the Grid Academy. And it's an EU Grid Academy. And it's not that we say that we have to see on how to organize that. There are a lot of questions ahead of us on how should we organize it, how should we govern this, should we work together with other institutions, should we work together with universities, should we put something on for which scope of people. But nevertheless, the need is there, and we are sure that it is of strategic importance for the sector to make that we develop a type of European Grid Academy.
Thank you very much. I think, look, you present a lot of solutions, a lot of to this problem, which I like. It's not only highlighting the problem from recruitment, these pairs of that learn from different backgrounds together, the collaboration, industry and academia, and also the initiatives that are taking place at E.DSO on the EU Smart Grids Academy. But for that, maybe Miguel Angel, you can help Luke. You have some ideas from the Smart Grids Skill project, how you think the project can contribute to maybe bring this to operationalize the European Smart Grid Academy and bringing content there.
I mean, the main challenge of this project, the Smart Grids Skill, is funded by the Commission, the European Union, is really to be sure that the industry, by one side, and I include not only operators, but also industrial providers, are defining clearly the needs, their skills needs. This is quite an important point. And taking into account that this is a kind of dynamic definition, because everything is being moving and is being modified almost every year. And by the other side, the providers of learning and teaching, not only the universities, but also what we call the vocational education training providers in another levels, are really understanding whatever is defined by the demand side, and they are able to provide. Taking into account very much whatever has been said also about the best practices. I know that, for instance, in France, there is a very good trend to go for the Grid National Academy. ESB has been already, on all of these examples are very well done in the DSO task force that you have mentioned. In the ESB in Ireland, they are really doing something that, in my opinion, is very much related to whatever, as a good practice, whatever you have mentioned, is a new way of recruiting. we are very much, let's say, old in this industry. We have to be absolutely tackling new ways of recruiting and taking into account that there are things like the skills-first approach, the micro-credentials use, which is very normally is a kind of an enemy to be set in a university, you know, the micro-credentials, but it's also quite important because in this way we would be able to take also a good effort that, believe it or not, is going to help us, is the migration. The migration with the micro-credentials could become a fantastic way of resolving things. So, again,
Miguel, sorry, can you explain what the micro-credential is? Maybe not everyone is aware. I mean,
well, micro-credential is just what it is being understood is really, I mean, a very focused, if you, on a curricula base, if you focused on a very specific theme, but it's giving you the opportunity of working on that aspect. For instance, let me put in a smart meter case. A smart meter case, if you go to a micro-credential for some expertise in the smart meter, if you give them a micro-credential that could be perhaps on a European-wide basis, that could open a way to speed up, you know, not only recruiting, but resolving problems. Mm-hmm. For instance, here in Spain, and now in Spain and Italy, very soon in France, there will be the second rollout of smart meters because smart meters have already arrived to their end of life. And now, the first thing that I am listening to the DSOs and the installers really, because at the end this is outsourced for installers, is the lack of people that are able to really use and to install the smart meters. So this is something that is going to happen tomorrow. So this is for micro-credential case. Yeah. So basically, coming back to my point, the project is being sure that the needs are well defined and the providers of training are absolutely aligned to that. And this is absolutely a fundamental point.
Okay, thank you very much. I think we can, Leo, I know that the Florence School have made a lot of efforts, and I imagine that you have a lot of plans to help on this challenge. And if we have time, maybe very shortly, we want to take people to work in the industry, but also we want to bring customers, especially the small residential, to participate into the electricity market. No? So that, can you have some recommendations to do that?
Yeah, thank you. I think this allows me to show that our school is also trying to provide some expertise on regulation, because we talked a lot about upskilling people so that they can be employed by this sector. But I guess we want to avoid that the sector becomes so complicated that you need an engineer in every household to be able to consume energy, right? So I guess we don't want necessarily that. So I think we can all acknowledge that complexity has a cost. But I wanted to start by also reminding us of the opposite, right? Simplicity can also be very costly. I think we should never forget that if we oversimplify. And I think if we connect it to flexibility, you know, at some point we were discussing, can't we just have an administratively determined compensation for when a DSO would use flexibility to curtail load or curtail generation? And then if you think about it, for just applying that to prosumers, it's not that easy to find even a normal compensation that makes sense. Because if you compensate enough for a consumer that doesn't have any PV or battery, that should be a rather high compensation. But then as soon as you have a battery at your home and you know you're going to be compensated for being curtailed at peak times, you would charge your battery during a peak time, right? While you're supposed not to do that. So I think, you know, simplicity can easily lead to gaming or weird behavior. And that's why we sometimes end up with schemes that maybe look a bit complex, but that are actually necessary, right? Mm-hmm. I think that also connects to flexibility markets, because if these two customers would participate in a flexibility market where you're procuring then you would discover that price in a way. So yeah, it's very complex to set up that market, but it can reveal some crucial information. But still, you can be at the mercy of gaming again, because if in that market you only have one battery owner participating, they can ask an unreasonable price, right? So what is then the solution to that? Well, that's why we are talking about more long-term contracting or flexibility connection agreements. But again, it means adding complexity to the whole framework. So does that mean that we are stuck? Is it too much? Not necessarily, because there I really like a CER paper from a while ago. I don't know if you've seen that, where they said, you know, we should stop talking about consumers as if they are all the same. And they had this really nice matrix to say, some consumers are engaged, others are not, right? Complexity can maybe cause some not to engage. But at least if we manage to engage them, then there are easy solutions to complexity. Because some customers like myself, honestly, I like to keep things simple, so I would maybe look for one supplier that offers me a full solution for everything, right? With automation and everything. And I don't necessarily want to play myself with flexibility, but if they give me a discount on my retail price, I'll be happy. So that's fine. While there are consumers, and I guess you might have talked to some of them during the coffee break at this conference or at lunch, that really like this complexity. They want to actually be able to have multiple suppliers and a separate contract with an aggregator, and maybe even do peer-to-peer trading and be part of a community and pick and choose, right? And that's, I think, fully okay if we all have that, especially if we then have some innovation, like some of the people that were on stage here, that sort of provide some automation to that and the latest apps to make that all possible. So we don't need an engineer in every household, I hope.
Thank you, Leo, for bringing the consumer also point of view to the debate, and that also we need them. We need these people, not only from the employees, but also from the consumer side. And maybe, Adrian, how technology can help to manage this complexity. I think Leo already said some ideas, but can you close on this? How, in general, the new technologies can help to solve maybe the two problems, or
yeah, sure.
Help.
Yeah, thank you. I see that timer is running as well, so I'll try to keep it short and close on some positive notes, I hope. So thank you for your previous interventions. It was really interesting to see that we're aligned on most of these things. Digitalization in grids is definitely the way the world is going now. I don't think the complexity will decrease anytime soon. We're rather going through more complexity through the increase of renewables, the increase of distributed energy resources. So this creates a complex environment, which is challenging, of course, but also offers a lot of opportunities, especially with data, for example. But to tackle these issues and to make the most of it, we definitely need engineers and data scientists. And the best of both worlds would be having these hybrid profiles. And these hybrid profiles should be the ones we're striving for, because they bring the skills to really understand and deal with this complexity. So as you said, it's not only about getting them right after they graduate, but also keeping them in-house with trainings and even vocational training and upskilling. And this is the idea of what the Commission is trying to do. So as I said in my introduction, we have two levers of approach. It's essentially through legislation and then through funding, because as Michael Engel said, it is very expensive to train people. And this is what we're trying to achieve first through legislation. The Commission published a Union of Skills, really to try and develop skills that will give quality jobs and quality lives, especially focusing on STEM education, including gender balance. So it might be a coincidence, but the panel today is not very gender balanced. So it's also striving to tackle these issues. It's also about having vocational training and upskilling throughout the life of workers and making them able to tackle the problems of tomorrow, especially with the increasing digitalization in the energy sector. And overall, it's also increasing digital skills and AI literacy that will be able to also bring people in different sectors, not only energy, but creating something that is lifelong. And finally, it's also about increasing the mobility and skills mobility within the EU, also attracting outside stakeholders, outside players, and outside skilled workers. So you've obviously seen the developments in the US. It's also an opportunity for Europe to bring in more researchers and bring in the skills that are needed to tackle the twin transition. On the other hand, I think funding is also needed to bring this to life, especially in the energy sector, as we're facing a lot of bottlenecks and skill shortages. So you already mentioned the E.DSO project, which gave a good appreciation of a good pilot and a good project to showcase what could be possible. And we also funded and you launched the SG Skill project focusing on smart grids. So that is going in the right direction. It's also more globally included in the large-scale partnerships for the digitization of energy systems. So very much focus on skills there as well. And I do believe that with these two pillars, we're able to make the emergence of hybrid profiles more likely. We're also retaining talents in-house, retaining skills within Europe. And this is also the foundation of everything and of the energy transition. So as you said, it's all about the human infrastructure. I think the title of this panel is very relevant. And investing in this infrastructure is key, because if we want to tackle societal change, if we want to reduce NIMBY, we also have to create a good vision for the future. And this includes training people, having people with interesting and skillful jobs. And this, for me, creates and completes the whole ecosystem towards the energy transition. Thank you.
Thank you, Adrian. I think it's a good summary of all the topics that the Commission are currently working. Yeah, time is about to finish. So maybe last thing is if you can choose among all these solutions that we have discussed, and let's try to finalize in a positive way. There are solutions, there are ways that we can try to attract new talent to the sector and to help on the training and use technology that we have currently available to tackle these issues. So if you have to choose one action to recommend the DSOs in the room and people from also startups and other to help them to find talent, what would it be? In few words, please, to keep it short. Maybe starting from Leo again and finishing here with Miguel Angel.
To be very short, I really liked what the previous speaker from LC Belta said at some point. He talked about the giggle test. I didn't know it. I looked it up, so it actually exists. So it means that in innovation, you test your idea. If everybody starts giggling, maybe the market is not yet mature. But on the other hand, if we never have an idea in this sector where people start to giggle, that's also not good. That means we're too conservative. So maybe we should make these compulsory giggle tests in all organizations so that people feel more welcome and that it's a fun sector to work in.
Interesting. Thank you, Leo.
That is a great idea. I think I mean, one of the actions I would choose would really be looking toward the future and really looking at young graduates, because it's all about also creating a new moral ambition for making the energy transition viable. And making it interesting to people, making it more sexy, I would say. And this would help us win also the war against other sectors. So I think it's all about innovations, about interesting projects, about funny projects maybe, but it's really looking at the future of people and the young graduates for me.
Thank you. No.
I suppose I continue in the same theme, and E.DSO has, really advocated for, training for campaigns. I think this is really important. I think we have really a mighty mission ahead of us, and I think that in itself is hugely rewarding and can attract people into the sector. And I think we need to make more of that. Even on our websites, everything, it's people want to do meaningful work. So you tell an electrician, you're not just wiring something up, you're actually helping to drive the clean energy transition, and that changes how you think about things.
Thank you. The problem is I have now that you ask for a positive closure, and I have only one message for the DSOs in the room, and in fact it's very short. It's innovate or die. If you do not follow this evolution which is coming to us, that you are lost. You lose the way, you lose the path, and you will never be able to exploit your grid for the future.
Not sure if that was so positive, but I will take it. Miguel Ángel.
It's easy for me. I mean, attractiveness is something quite important. I really believe that this sector is already late. But if I have to select just a sort of end, is as I started at the beginning. Talent is a matter of investment. We had to deliver this specific message to the top deciders in our companies. We need investment.
Thank you for your good ideas. I hope people here in the room take them into consideration. And thank you for being here. Thank you.
Thanks so much to our final panel. Thank you to our moderator, Juan Pablo Chavez. And now I'd like to call our board member, Vice Chair of E.DSO and Chief Transition Officer at Stedin, Timo Idema, to the stage. I see him there to give some closing remarks on behalf of E.DSO. Welcome, Timo.
Hi, everyone. It's an honor to be here as we're concluding the second FutureGrid Innovation Summit. And it's an honor to do so on behalf of the E.DSO Board and Executive Committee. And I have the kind of dubious honor of being the last speaker. And when I was preparing for this, I asked, so that means I'm kind of in between the end of the program and drinks. And now I hear there are no drinks afterwards. So I think we have to maybe find our own and change that. But I'll try to keep it brief and try to wrap up what's been a long day with, I think, insights in a very broad spectrum. As Charles mentioned, I'm the Chief Transition Officer, one of the 4 board members of Stedin. Stedin is a Dutch DSO, one of the 3 larger DSOs. We operate the electricity and gas networks in the port of Rotterdam, 3 of the largest Dutch cities, so Rotterdam, Utrecht, The Hague, and we do both electricity, gas, and heat. And I understand I shouldn't be speaking about gas here, so I'll try to limit myself to electricity. And what I love about this job, and I think, and what I love about working in the energy transition is, one is the people I work with, and that's the case in the Netherlands, but it's also my international colleagues. But it's also the impact we can make. And if I look at the impact we can make, there's always a negative way of framing that and a positive way of framing that. And I like to end on a positive note, so I'll start with the negative. The negative way of framing it is, if you look at the energy transition in the Netherlands, we're a blocker at this moment for our competitiveness. So we have network congestion. It means companies cannot invest in electrifying because we have a wait list. So the Port of Rotterdam at this moment has a wait list. So companies looking to expand are waitlisted. If you look at from a security perspective, I think we're increasingly dependent as countries on other countries and outside of Europe energy. So that is quite a challenging one. And actually, we're not meeting our climate goals at the moment. So the Dutch outlook and the Dutch ambitious climate targets, we're not meeting. And one of the factors is also network congestion. So that's a negative side. But the positive side I'd like to see there is, it's actually, we are there to enable these things. We are there to enable competitiveness. We are there to enable European energy security, European autonomy, and we're there to enable the climate transition. And that's really what motivates me. As I look today, one overarching insight stands out. And that's the grid of the future will not just be determined by how much we build, but it will be determined by how intelligently we build, operate, and integrate it into a rapid changing energy system. Throughout today, we've heard that Europe is mobilizing unprecedented investments in its energy infrastructure. And year on year, we see these investments increasing. This is necessary, but investment volume alone will not determine success. What will determine success is whether we manage to translate these investments into a system that is flexible, that's digital, that's resilient, coordinated and supported by the right people, and the right people with the right skills, as we just heard in the last panel. But going back to the first panel, it explored what it truly means to invest smarter. A cost-effective system is not one where we simply add more cables and substations. It is a system where flexibility is embedded as a core resource. It's a system where digitalization allows us to see and use the grid differently, and where coordination between transmission and distribution system operators prevents the fragmentation and unnecessary costs. Just to give you one example, one of the decisions we have in the board in the next weeks in my board back in the Netherlands is whether we bundle more of our IT developments together as DSOs in the Netherlands, together also with the TSO, such that we develop a joint IT infrastructure rather than each of us developing our own. I think that's exactly the kinds of developments we need for this future system. So we heard clearly that system users must be enabled to become part of the solution, supported by transparent data exchange and regulatory frameworks that reward efficient system behavior. And just to give you an example of that from my own practice area, we have huge network congestion issues in Utrecht. That's a central province in the Netherlands. And one of the insights, of course, was, well, electric vehicles shouldn't be charging at peak moments. They used to be. Everyone comes home at 5 o'clock, puts their EV in the grid and starts charging. So we're now moving into contracts with these charging points to move them to the night. That makes a consumer, rather than adding to the peak, takes them away from the peak. But what we're also doing is we have the first vehicle-to-grid cars in the Utrecht area. And vehicles, instead of adding to the peak, are actually actively helping to reduce the peak, because these vehicle-to-grid vehicles are actually discharging at our peak moments, thereby creating space on the network rather than adding to it. And that, I think, is where you see the future. It's a future where customers, consumers, can actually earn money by being part of the solution, and become part of the solution than part of the problem. But that needs support from a transparent data exchange, regulatory frameworks that reward this efficient system behavior. And we were reminded that flexibility is not just an accessory to grid expansion. It is a system resource that we must plan for, we must regulate for, and we must invest in. And the focus shifted in the second panel towards what is happening actually in the electrification trends. Electrification of transport, heating, and industry is accelerating everywhere in Europe. Yet, if I speak for my own country, we are behind target on most of these transitions. We would like to move faster. And again, grid congestion is an issue. The challenge of distribution system operators is to ensure that electrification strengthens the system instead of creating new bottlenecks. I just mentioned the example of cars, but we also see the same example with heat pumps. Heat pumps can buffer at the moments that there is excess supply and can actually go off the grid at the moment we have peak demand. So we're increasingly working on such systems. What became evident is that the assets connected to our grids, electric vehicles, heat pumps, smart appliances can provide the flexibility that makes electrification affordable and manageable. But again, this requires clear market rules, interoperable technologies, and the ability to move beyond pilots towards mature and scalable services. Now, mind you, flexibility is not a silver bullet. It is an important cornerstone and an essential part of a balanced solution. And finally, one of the key parts of the grid transition was and is the human transition, as was just mentioned in the third panel. The future grid requires traditional engineering excellence combined with digital and data expertise. But we also need something else, and that's in order to get those consumers to come along, we need people who understand marketing. We need people who understand proposition development, and we need people who understand how you get efficiently operating liquid markets. So we also need economists. And across Europe, we face a tightening labor market, where you see that the skill requirements are changing rapidly. And in our case, that is one of the main bottlenecks actually to being able to invest faster than we would like to. We just can't get enough of the right number of engineers and the people who do the work outside. Strong cooperation between industry, academia, and policymakers is key to ensure that the workforce of tomorrow is ready to build and operate the designed system of today. But what connects all these discussions is a broader European ambition. The direction we discussed today is not only necessary for a well-functioning energy system. That is never a goal in itself. It is essential for Europe's energy security and sovereignty, for achieving our climate goals, for strengthening competitiveness, and for keeping energy affordable for our citizens, especially for our poorest citizens. In that sense, this is a win-win-win on all fronts. The European Commission has placed competitiveness at the center of its agenda. A competitive Europe requires an energy system that is reliable, resilient, affordable, and capable of integrating innovation at scale. And this is exactly where distribution system operators play a crucial role. The recently presented European Grids package recognizes this by placing grids, flexibility, digitalization, and system integration at the heart of the energy transition. It underlines that grids are not a passive backbone, but an active enabler of Europe's economic and industrial future. Now, if we want our grids to support this ambition, we must ensure that we are ready to integrate innovative solutions quickly and effectively. I think we are all aware that these innovations are available. And yes, some of them might make us giggle, as was mentioned in the last panel. But I think our biggest challenge is also to get these innovations implemented at scale. One of the things that this requires is open standards, interoperability, and regulatory frameworks that allow these technologies from different providers to work together seamlessly in our networks. We don't want that one battery operator that was just mentioned because it has unique access to the system. We want many batteries to be competing for flexibility on our grids. That's when it becomes efficient, and that's when it also will help us at scale. By creating an environment where innovation can be deployed at scale, we strengthen both our energy system and Europe's ability to turn technological process into real system value. For us in the Netherlands, system value is a very concrete and urgent topic. We are learning that system value is not just about cost reduction. It's not just about having the most affordable system. It really is also, in our case, about access. As I mentioned in the Port of Rotterdam, the fact that we actually don't have these flexibility arrangements in place right now is what is keeping us back from having investments in new industries. Rising system costs and a lack of timely access to grid capacity threaten the competitiveness of our companies and industry, but policy reports have presented us the options to limit the system costs. It was empowering to learn today how these solutions are developing all around Europe. If today has shown us anything, it is that the future grid will emerge from intelligence, integration, and human capability. Europe does not lack innovation. It has plenty of innovation. Europe does not lack ambition. But what we must now ensure is that innovation reaches our grids at scale and at speed. Together, we can make this possible. And if I look around the room today, I see different groups. I see DSOs. I see market parties, so industry. I see regulators and policymakers, and I see academia. And I think what is required to make these innovations really come off the ground is that we find each other. Because it is only when regulators find ways of creating the agile, open frameworks that allow for these innovations to come into markets that we can actually get market parties to earn money with being part of the solution. And it also requires DSOs to set the right standards, to do the right, to have the open standards and open data access that allows market parties then to work together. So it is actually that not just about us each individually doing our part, but it is very much about what we've been doing today, and that is coming together and finding the solutions that make the entire system work, that will help us reach these goals that I mentioned that make me so enthusiastic to work in this sector. It is what makes us work towards a secure Europe. It's what makes us work towards a competitive Europe, and it's also what makes us reach our climate goals. Let us leave here not only inspired, but committed to turning these insights into action. Because if we succeed, our grids will not become a bottleneck for electrification, but a driver of European competitiveness, resilience, and prosperity. Let me close off by thanking all the event sponsors, EPRI, LCP Delta, and FlexiGrid. The event partner, Energyville, all of you participants, and last but not least, the entire E.DSO organizing team. Thank you very much.
Thank you so much, Timo. And with that, we'll close for the day. We don't have formal drinks, however, we can still have a quick chat afterwards, so please feel free to stay for a bit. And I wish everyone a great rest of the day and look forward to seeing you again next year at our next edition. So thanks very much. Thanks to all the sponsors. And I also would like to take this opportunity to thank the E.DSO Secretariat organizing team, particularly Paula and Veronica, but the entire organizing team. So thank you very much.